In the previous video, we have made the following assumptions about the consumer. 1. Rationality and perfect knowledge. 2. Completeness. 3. Transitivity. And 4. Non-satiety. Now, using these assumptions, let us define indifference curves. Now consider this diagram where you have quantity of apples on the horizontal axis, quantity of oranges on the vertical axis, and let us plot this point A, which is 2, 3. That means we have 2 apples and 3 oranges. Now let us divide this diagram into different quadrants. Let's just do that. Different quadrants. Now let us look at a commodity bundle like B. And what is B? We have 4 oranges and 2 apples, and we know B must be preferred over A. Similarly, if we had a commodity bundle here, again that commodity bundle will be preferred over A. Or in general, if we are anywhere in this quadrant and we have a commodity bundle in general, any commodity bundle like B, any commodity bundle in this particular quadrant must be preferred over A. So let us just write this. Now let us look at a commodity bundle. Let us call this F, where we have 1 apple and 3 oranges, and we know because of non-satiety A must be preferred over F. So if you have any commodity bundle in this quadrant, what you'll find is A must be preferred over any commodity bundle in this quadrant, and we have been calling this F. Now look at another commodity bundle. Let's call this C. Let's plot this here. And here this person has 3 apples and 2 oranges. Here we cannot say for sure, or we cannot be sure whether A will be preferred over C or C will be preferred over A. A similar thing applies to a commodity bundle. Let's just write D here. And here this person has fewer apples and more oranges relative to A. Again, this person will have to tell us whether he's equally satisfied between A and D or not. And so we have these points, and what we can do is we can plot more points like these where the consumer tells us that this person is equally satisfied between A and any commodity bundle, either in this quadrant or in this quadrant. So when you join these points, what you get is a curve, and this curve is called an indifference curve, or IC in short. So IC is simply, or indifference curve is simply a collection of points which give equal level of satisfaction to the consumer. Now we are in a position to define what we mean by indifference curve, and based on what we know, it is simply a collection of different points representing different commodity bundles that give the same level of satisfaction to the consumer. Indifference curve. And based on the previous diagram, you already know the first property of an indifference curve, and I'll be using IC in short in place of indifference curve. And what we find is an indifference curve is usually downward sloping, and this is the first property of an indifference curve. In this diagram, once again we have quantity of apples on the horizontal axis, quantity of oranges on the vertical axis, and now what we have are two indifference curves, IC1 and IC2. Now based on the assumptions that I have made, I can make a statement that IC2 implies higher level of satisfaction relative to IC1, or IC1 implies lower level of satisfaction relative to IC2. Why does this happen? Look at the following. We have a point like B where you have 2 oranges and 3 apples, or 3 apples and 2 oranges. And then we have a point F which is on IC1, which is 1 apple and 2 oranges. Because of the assumption of non-satiety, under B relative to F we have this more apples and the same quantity of oranges, or in other words, B must be preferred over F. This must be true. Or in other words, any point on IC2 implies higher level of satisfaction relative to IC1. So based on the previous diagram, we get the second property of indifference curve, and that is an indifference curve further away from the origin implies higher level of satisfaction to the consumer. The opposite is also true, that is, an indifference curve closer to the origin implies lower level of satisfaction to the consumer. Now let's move on to the third property of indifference curve, and that is two indifference curves can never intersect. It's just not possible given the assumptions that we have made. To show that two indifference curves cannot intersect, let us use the method called proof by contradiction, and that simply means whatever we believe cannot happen, let us assume that it is true, and so two indifference curves IC1 and IC3 do in fact intersect. Now look at the following. We have this commodity bundle A, and then we have a commodity bundle B, and then we have commodity bundle C. And what you find, given the assumptions that we have made, is the person must be indifferent between A and B. Why? Because these 2 points lie on the same indifference curve. By similar reasoning, this person must be indifferent between A and C. Why? Because A and C lie on the same indifference curve. What about B and C? What you find is under B and C you have the same quantity of oranges but fewer apples relative to B, or in other words, B must be preferred over C because of non-satiety. And because we know these two statements are also valid, that means this person must be indifferent between B and C. So here what we do is we find two contradictory statements based on the assumptions we have made, and hence this is not possible, and that means two indifference curves can never. The fourth property of an indifference curve is that it is convex to the origin. Now when we say that indifference curve is convex to the origin, that means if you're looking from here, you can see this curve is convex to the origin. Now look at the following. What does convexity mean? Or to get this kind of a shape, suppose you decide to increase consumption of apples, say from 2 to 3. How many oranges do you give up? These many. And if you decide to increase consumption of apples, say from 6 to 7, 1 unit, how many units of oranges do you give up? Very little, very little. And or in other words, what is happening is the following. Suppose this point is A and this is B. So if you want to move from A to B, you are giving up quite a large number of oranges. But if you move from a point like from C to D, you're giving up fewer oranges. Or in other words, what will be the slope of indifference curve? It will simply be change in oranges, I'll just write O, divided by change in apples. And we know this number will be negative, so let's just take the absolute value of slope. And what will that be? It will be a positive number if you take an absolute value. And what you find is, as you increase consumption of apples, the absolute value of slope of the indifference curve falls, and when this happens, this gives rise to convexity of the indifference curve. Now, based on the previous diagram, we know for an indifference curve to be convex to the origin, what we require is the absolute value of slope must decline as we move down an indifference curve. Now, slope of an indifference curve is called marginal rate of substitution. And what are you substituting? Apples for oranges when you move down. And we can abbreviate this as MRSAO because we'll be using it again and again. So here is a formal definition of marginal rate of substitution between apples and oranges. It's the amount of oranges you would give up to have the same level of satisfaction when you increase consumption of apples by 1 unit. And this is how we define marginal rate of substitution. And if we want convexity, what we require is, in an absolute sense, marginal rate of substitution must decline as we have more and more apples or we move down a given indifference curve. Now we can write down the fourth property of indifference curve in a more formal way, and what we require is diminishing marginal rate of substitution between apples and oranges. And what does this mean? As we increase consumption of apples, marginal rate of substitution must decline in an absolute sense. Or in other words, what this means is, as we have more and more apples, the less and less willing we are to give up oranges. This property is called diminishing marginal rate of substitution. Why does this happen? You should think about it, or maybe read it in the textbook. It's an important question, a fact of life. Why does this happen? So now we are done with the assumptions as well as properties of indifference curves. And next time what we'll do is, in the next video, we'll bring budget constraint and indifference curves onto the same diagram. Here is a summary of different properties of ICC indifference curves. And the first one being, indifference curves are usually downward sloping. The second one being, an indifference curve further away from the origin implies higher level of satisfaction. The third property being, two indifference curves can never intersect. And the fourth property, diminishing marginal rate of substitution.